So I think we are live.
Boa tarde a todas e todos. Começando aqui mais um episódio do Firetalks da URGS, um programa que visa difundir o tema da segurança contra incêndios, focado em apresentar assuntos relacionados à sociedade, aos profissionais atuantes e à área acadêmica. Hoje, 15 de dezembro de 2022, temos dois assuntos especiais para apresentar para todos vocês. Um é o próprio tema da conversa, a modelagem da evacuação, em caso de incêndio, que requer conhecimentos tanto tecnológicos quanto de comportamento humano em caso de incêndio, e também uma certa criatividade para bolar situações que podem acontecer durante os sinistros, né? E o outro assunto especial é o nosso entrevistado, o Dr. Enrico Ronchi, de Lund, Suécia, e que tem uma atuação destacada na área, com participações em pesquisas junto a instituições internacionais, como a NFPA, entre outros, e diversos países. E também é autor de quase 200 artigos científicos e editor-revisor de diversas revistas especializadas sobre o tema. O Enrico esteve aqui no 7º GSA em 2019, em São Paulo, e foi quando a gente conheceu ele através de uma palestra. Esse episódio, de forma inédita, ele será hoje transmitido em inglês, e aí, portanto, eu vou ficar quieto, e quem vai comandar é a Ângela, a Brenda e a Morgane, né, que vão falar com o Enrico, e logo em seguida depois a gente vai deixar o episódio disponibilizado no YouTube, daí devidamente legendado. Então, hi Enrico, seja bem-vindo ao nosso Firetalks, e eu passo para a Ângela.
Hi Enrico,
Thanks for
welcome to our welcome to our 11th Firetalks episode, and thank you for accepting the invitation to be here today with us. The idea of this program is to chat and talk about fire safety issues, and today we are going to discuss some issues related to the fire evacuation and evacuation modeling. This is going to be our first episode in English, so we are really excited for it. And so just to introduce myself, my name is Angela. I am a civil engineering professor at the Federal University of Rio Grande do Sul, and this is our Fire Talk team. So Brenda, Morgani, and Evandro Babu. So it's really nice to have you here with us. We're really excited for this chat today. And so I'm going to start asking a question. It's like a personal question. So fire safety engineering is a recent discipline all over the world, especially when we consider the developing countries where fire tragedies occurred later in comparison with other developed countries. Here in Brazil, there are a few scientists, and this includes professors, graduate students, and researchers in general working in the area, and many of them are developing research in the materials area. So the first question we want to know is related to the reasons that made you to start developing studies in the fire safety engineering area. So it's like a personal question.
Yeah,
and please introduce yourself also. I just started speaking, and please.
Sure. First of all, thanks for the nice invitation. And as you said, my name is Enrico Ronchi, and I'm an associate professor at the Lund University in Sweden. And as many other researchers that work in the domain of fire safety, we almost happen by chance in this domain. So my history is that I started as a civil engineer with a specialization in transportation engineering. And then back now it's 15 years ago, I worked on a thesis in the domain of tunnel safety, and I approached the world of evacuation simulations. So I am Italian, you probably can hear the accent. So I was at the Polytechnic University of Bari in the south of Italy. So I would say a very nice climate, sunny side of the world, similar to Brazil in a way.
Exactly.
And then after that, this opened many doors for me because I started working with the simulations of evacuations and UMB ring fire, So I spent part of my PhD working here in Sweden at Lund University, and that's how I got to know the group here, because here they have a dedicated department of fire safety engineering, so it's specific to fire safety. And then after this, I was one of the classic globetrotters of research, because I was working for some time at NIST in the United States, in the National Institute of Standard Technology in Maryland, where they had a very big stream of research on evacuation after the World Trade Center disaster, because this opened a lot of interest in the domain of evacuation. And after that, I spent some time in Germany, where I work at the University of Würzburg, and there I was working more on the psychology side of things, because I was in a group of psychologists, and there I started learning about new ways and new technology to study human behavior in fire. So more specifically, using technologies like virtual reality and not just simulations, but like how we can simulate an environment that looks real, so that we can study how people behave in a fire without exposing them to the real risk of a fire. And after this tour, then Lund University offered me a position, so I'm now back in Sweden. Now it's 10 years that I'm back in Sweden, almost 10 years, and I'm now an associate professor here, where I lead the group that works on evacuation, and we mostly work in both the domain of behavioral experiments, so to try to understand the response of people when there is a fire emergency, and in the domain of modeling. So how can we then create tools and models and simulators that can be used for engineering design. So I also, let's say, come from a place where it was not a huge tradition in the south of Italy, where I come from, in the domain of fire safety. But as I said, coming from the domain of transport, I entered that world, and then having the opportunity to work with some of the biggest groups that are in the domain of fire safety, I could learn more in the domain of evacuation. And now, as I say, I have an active research track in the domain of evacuation and human behavior in fire, keeping in mind that we are not so many around the world, the researchers that work with this topic. So it's a very specialized topic, which in a way, it's not so good, because it's not a very big community. But in another way, it's very good, because we are a very close community. So we pretty much all know each other, the ones that work in this domain. So we're all, let's say, good friends, not just colleagues. So that's the trajectory that led me to work into this domain here in Sweden. So very different climate here in Sweden.
Yeah, I was going to tell you that. So very different from Italy, for sure.
Yes. So it was a climate shock.
So you said you were also in Maryland in the US?
Yes. So I worked for some time in Gaithersburg in Maryland. There is the National Institute of Standard and Technology.
Yeah.
That is a governmental agency it's part basically of the Department of Commerce of the US. And again, there I got to know some of the big names in fire safety, because it's very much known, that research group, for the work they do on fire simulation, because they are the developers of FDS, which is the fire dynamic simulator, which is probably the most used simulator of fire in the world. But they also have a research track on evacuation. So there I got to work with the people that work on the federal investigation of the World Trade Center. So studying how people behave during the terrorist attacks and during the fire associated with attacks.
Yeah, I asked that because at this moment I am in Maryland.
Okay.
I'm a visiting professor at the University of Maryland at this moment.
Okay.
So that's why I'm wearing coats, and they are wearing like summer clothes.
Okay. It's a nice place to be. I've been visiting also University of Maryland, of course, so I know a few of the professors that work there in fire safety, because of course they have a very known research group in fire safety.
Yeah, they have a department of fire protection engineering, and also I was very surprised because they have even a undergraduate course for fire protection engineering. and this is something we don't have in Brazil, at least.
And that's the same as we have here in Sweden. So here we have both an undergraduate course in fire protection engineering for our local Swedish students, and we're also part of an international master program. This is has been running now for over 10 years, and I'm, by the way, the responsible of that education here in Lund, where we have partners. The main partners are University of Ghent University in Belgium, University of Edinburgh, and the Polytechnic University of Catalonia. So some of the biggest players in Europe when it comes to fire safety. And one of our associated partners is University of Maryland. So we have
that's good.
our program.
So I'm going to ask you the next question. So in Brazil, even though some states, São Paulo, were involved with the development of the fire safety area since the 70s, our society still depends on tragedies, such as the Kiss nightclub and the National Museum fires, to show some kind of interest in preventing the fires to occur. So in your opinion, how you see this aspect, especially having acted in different countries and cultures, how you see this aspect?
Oh, of course, I would say the safety culture is different in different parts of the world, but I would say that this concept of design by disasters, some people call it. So when there is a disaster, people wake up that there is an interest in a topic and we need to do something about it. Unfortunately, I would say it's a common problem worldwide. And I mean, we see this in Europe, for instance, after all the debates that started on fire safety, for instance, of high-rise building, after there was the big fire and the Grenfell fire in the UK. So, I mean, I would say in certain countries, there is more history of research and also code developments, which is very linked to education, I would say, because generally those countries that have educational program in fire safety engineering, they also have more educated people that can down the line work also on the codes and with the codes. So it's indeed not surprising that there is generally more awareness of fire safety. But it is a common problem, I would say, worldwide, that the huge interest and the huge spotlight on a topic comes when there is a big disaster. And I mean, I can relate to many big disasters that happen in Europe that have raised debates and led to changes in regulations, codes, and general interest on the topic. For instance, maybe this could be interesting for you here in Sweden. A couple of years ago, there was a big nightclub fire, in a way, with some that we can compare to what you've seen recently with this nightclub fire in Gothenburg. And that, let's say, opened a huge debate on the importance of fire safety and how to deal with this kind of very crowded place where you might have more negative consequences of fires. But then when we digged more into, and there are many research that looked into this, often it's mismatch between what is supposed to be done versus what is happening. So, of course, codes are not perfect, but often when something bad happens, it is likely to find that things were not designed according to the code. And when it comes to safety of crowds, it's often the case that you have too many people compared to what are supposed to be in a given place. So that's a common problem when it comes to crowd safety and evacuation.
Enrico, now talk about the research area and in the benefits that modeling can bring to the fire safety area. How do the human behavior is included in the modeling? For example, here in Brazil, the Brazilian society that still seeks to consolidate the risk of perception, the human factor is still seen as unpredictable or not as trustful as it should be. How do you cope with the unpredictability in case of fire?
Yeah, it is a very good question, and it's very much linked to the research that I do, because one of the main contributions that I've been working on as a researcher is in addressing this uncertainty, what we call behavioral uncertainty. So while when we study fire dynamics, there is Of course, also there are some uncertainties, but often we use so-called deterministic models. So a model that if you put a set of inputs, they will always return the same output. When we deal with human behavior, we can't really use this approach because we definitely do not know when there is a fire if a person under a given condition will take 1 minute or 2 minutes or 30 seconds to react. But what we know is a reasonable range of responses across the population. So we know a certain type of a population under certain circumstances might react in a given way, which means that we can use so-called probabilistic models, or some people call it stochastic models. So models that look at probabilities. So what is the probability that this will happen in this fire and the people will react in this way? And often the behavior of people is split into two different phases. So the phase that is so-called pre-evacuation or pre-movement. So what people do before they actually take an active decision to move towards a safe place. And then there is the movement, which is actually going from point A to point B or to a place of safety, or doing a certain, we call it behavioral itinerary. So taking a certain itinerary before reaching a safe place. So the critical part often is the first part. So it's very, there is much more uncertainty there often when it comes to try to understand how people react and perceive risk. Because again, this depends on many factors. It depends on the type of people that we have, depends on social influence, because we are not taking decisions just by ourselves, but we interact with the other people around us. While instead, when it comes to the movement phase, especially when we have more crowded situations, there it becomes almost a flow problem. It becomes something that we can relate much more to models that come from the world of hydraulics or physics. So it's like a system of particles that move. It's often the methodology that you use to model this. And then it relates more to physics. So if you have a certain number of people in a space or they pass through a door, we can tell how many people maximum can pass through that door. That we know it from the scientific point of view. It's much harder instead to say how they will react and what they will do. So we need to use more probabilistic approach, or more try to address this kind of uncertainty. So one of the research area they have been pushing a lot since my time indeed in the US was to develop mathematical methods to study these behavioral uncertainties. So to address the fact that when we run an evacuation simulator, we don't get always the same result. We might get different results because the models use distributions, use probabilistic approach. So people call it Monte Carlo approach sometimes, but the correct technical term would be pseudo-random sampling. So we have a distribution and we sample value from this distribution. And then it means that at every time, it's like rolling a dice. Every time that you roll a dice, you can get a different number. So you need to then study what is the outcome, not of one individual scenario, but of all the scenarios together. So my effort has been put in developing mathematical models that help understanding and interpreting these probabilistic results so that we can have a better idea.
Do you usually correlate these mathematical models with experimental results? I mean, you do simulations and then you can compare them, or I was curious. I mean,
that's how it works. So the idea is then when you work with the validation of evacuation models, you need to try to compare not just one simulation to one experiment, but ideally you should have repeated experiment, repeated data from a very similar condition versus a repeated number of simulations. And the problem is that sometimes it's very difficult to find the same experiment repeated multiple times. Now, as I say, in the last years, there is more and more researchers that have tried to do this systematically. So to try to investigate under the same condition, a given scenario, and see how are the possible range of outcomes. And that is exactly what we need to use for validation of the models, because it allows us to see, okay, this is the range of results that our models produce versus this is the range of results that our experiments are telling us. So how much do they overlap? So how far they are from each other? Are they very close or they are very far? And then you can use methods to try to understand closer what you need to change your models to get a better prediction and a more valid prediction of human behavior and evacuation movement. I cannot hear you, Angela.
I'm sorry. It wasn't muted. So we saw, looking through your published papers, that you use many softwares for the evacuation modeling. So how do you choose which software is more appropriate? Does it depend on the building type, the occupation, the country where the building is located? And also, another question related with these softwares. Do you have any communication with the developers of the softwares, especially in terms of collaboration between academia and industry? Or how does this work?
I mean, the way it works is that I've always been very open to not, let's say, use only one tool or one software, because I think that there is for every job, there is probably the right tool. So rather than having an upfront decision on what software to use or what tool to use, it's better to first see what kind of modeling approach is best for that specific scenario. So it's now several years that I've been collaborating with different model developers, both of commercial software, so software that are available on the market from commercial companies, as well as from researchers. So like there is a couple of known open source software that are available for this. So the idea is always try to understand what are the assumptions, the core assumptions used by a model. So for instance, what is the way they represent the space? Because you can, in different models, you can have more simplex or more complex representation. So for instance, some models make use of a network, so they're more network models, or a grid, so you have a mesh with different cells, or some models are so-called continuous models, so they're more like a vector system or a system of coordinates where you track people movement. And depending on what is your interest, there may be a good model or a bad model for that specific application, because there is no like model that is good for everything, but you should be able to find models that are flexible enough to deal with a specific case that you're dealing with. So my suggestions for people that are using those models, that they have to choose which model to use, assuming that they have, because I also acknowledge that if you are an engineer or an architect and you work with this, you also have a cost for this. So some are more expensive, some are cheaper, some are open source, and I know that. But in an hypothetical world, let's say that we have them all available and we can choose freely, what I would recommend the user is to first check what are the main variables that they're interested in. So for instance, if you have a very sparsely populated environment, so like think about a road tunnel when there is not too many people, maybe it's not so important to have such a detailed representation of the crowd, because you will not have so many people in there, but it's much more important to study the interaction between the fire and the people, because you have a single compartment. So you don't have like different rooms, but the tunnel is a whole single compartment. While instead, if you have a very crowded place, think about a shopping mall, a nightclub, one environment which you have much more people in it, then it's much more important that you get to use a model in which the crowd is represented in a more accurate way. So when you go for scenarios in which you have higher densities, so many more people in a given space, then you need to be careful, because you need a model that is able to represent those densities. So if you use, for instance, a grid-based model, you will have a lot of problems in representing very high density scenarios. So that's when it's better to use, for instance, the so-called continuous model, which instead track coordinates of people when they move. So the recommendation there will be to first check what is the scope of your application, what you're interested in, and then review what are the main core assumptions that these models use. And then, let's say, weight the benefits, pros and cons of the different models, and try to find the best fit for your scenario.
Perfect. I will try to just ask one question from the audience, which is somehow related to what we were just talking now. So one of them is from Felipe Centeno. There is one also from Gabriele, but I will leave it for later on, just because I will put Felipe just in front, because this is somehow related to what we were talking. So Felipe is asking, since in Brazil people are not trained on how to react during a fire, there are no fire drills, for example. Is it still possible to run evacuation simulations by setting up specific parameters for this kind of untrained population?
Yeah, I would say nowadays there are models that are enough flexible to study very different type of populations. So from those that, let's say, that are very trained and they have a very short reaction time, for instance, because they are trained to do that and to react very quickly, to those that spend more time in investigating. So as I mentioned before, some models nowadays allow the representation of so-called behavioral itineraries. So what is a behavioral itinerary? Is basically not a person that go just straight from point A to point B because knows what to do and maybe is trained and maybe is familiar with the environment, but more complex behaviors in which people are also investigating. So maybe they go from a point A to point B where they are looking what is happening or interacting with other agents, and then go from point B to point C to investigate more. So you can have more complex behaviors, but of course the model will be as good as the efforts that you put in trying to do this type of mental modeling, or some people in research, they call it behavioral sequence representation. So to try to reconstruct what are the possible sequence of actions that will occur in a given scenario and with a given population, and then being able to represent it in a model. So the models nowadays are flexible enough to do that, but of course it is much more work for the user to try to reconstruct what possible could happen. And again, very likely it will not be only one possible scenario that will happen. There will be many possible different responses. So you need to use a more probabilistic approach, trying to represent different scenarios and see what is the possible outcome based on these different scenarios, and then make an assessment into, okay, this is the range of my possible results, and how much I'm far in this range from, let's say, what is the time that I have available to exit the building. Because we should always remember that one of the main applications of these models is the so-called performance-based design. So taking an evacuation model to simulate how long it takes for a building to get empty, so to evacuate it, versus how long it takes for a building to become untenable, so that you have fire conditions that may lead to intoxication, may lead to negative consequences in terms of the effects of the fire and the smoke. So this is the type of comparison that we do. So then when we have these probabilistic models, we know that we have a range, and maybe we have another value that we get from a fire simulator or from a hand calculation of fire simulation, and we can see how far we are. If, of course, the time that we have available is lower than the time that we need to escape, then that building is no good, because it means that people will remain trapped inside. But if we put enough safety margin, then we can be more on the safe side. But then, since you have this kind of probabilistic approach with evacuation models, you have to see how far are you when you compare those things, and how much risk as a designer you can take, because then it becomes also a matter of money down the line, how much money you are spending for safety. And again, this is one of the things that we should always be careful on, because we cannot think that safety is something that we can really be cheap on or try to save money on. I mean, our priorities should be life safety, so should be to try to have enough margin of safety to consider the building safe enough. But I also want to highlight that the risk zero does not exist. So there will always be a small portion of risk, even if you do your best. But you have to try to keep that risk to as low as possible. That's the effort that we need to do as designers of fire safety, to try to decrease that risk as much as we can.
Enrico, there are many people asking things in YouTube on YouTube. Morgane, can I just ask another one? One from Gabriele, the first one. She asked 2 questions. I'm going to ask you the first one. So she's asking, what's the biggest challenge you or your group are facing when researching evacuation modeling?
Well, the main issue nowadays is data availability, because when it comes to modeling, technically we can model everything. So nowadays there are super complex models, super advanced modeling techniques, AI models, like all sorts of complex modeling methods that go from agent-based, AI, and so on. But the models will be as good as they are close to the real world. So it cannot be just a modeling exercise we are not computer scientists. At the end of the day, we are engineers, we are architects. So we need to use these simulations for designing real buildings, for addressing real fire safety challenges. So the main challenge that we have as researchers that work with simulations is to get hold of good data that we can use to back up the assumptions that we use in this simulation. So it has to be always substantiated, so also always supported by data that help us calibrate our models so that they're close to reality. Because again, a model can be, and I had this chat many times also with people that come from other fields, that come, for instance, from the field of applied mathematics. There are some mathematicians that are brilliant in maths, maybe much better than all of us, and they publish models about crowd simulation, evacuation simulations in mathematical journals. And if you see the maths, they are very good, it's brilliant and everything. But then my question is always, how close is this to the real life? So when you see things like people that are modeling the so-called panic, irrational behavior, that we know that is not like necessarily linked to the real world behavior, because even in the most extreme situation, often we can reconduct behaviors to rational behaviors, even when people are facing very extreme scenarios. Also, we can find a reason why people act in certain ways. So when we see models that are trying to model something that in real life doesn't occur, even if mathematically they're beautiful, they're not useful for us as engineers and architects, because we need to get models that are close to the real world. So the effort that we all need to do is to validate this model with real world data. And sometimes it's not so easy to get hold of this data. So it's not always easily available. And people like me also are involved in trying to collect this kind of data, because, you know, it's not, fortunately, that fire occur every day. So we don't have data from real cases every day. So we need to arrange experiments, arrange fire drills. We need to collect data in many ways. As I said, nowadays we can collect data with virtual reality. We can connect data with different type of sensors. I have some colleagues that have used very sophisticated sensor techniques to track people movement, not just cameras. Nowadays there are, for instance, depth sensors that can track your position with very much accuracy. Or there are other groups that start using your phones to track where you are. So you can just pin to your phone and see where you are in a building with a certain accuracy. So nowadays, there are more and more research techniques that look into exploring how we can understand human behavior and how people move during an emergency. But it's not so easily accessible for researchers, because often if a fire happens or if something bad happens, the last thing that the owner of a building wants is to have a researcher to look into what was going wrong. So
For sure, yeah.
Often it's just these big cases that end up in the news, in which there is a big investigation made by the state. That those ones are the ones that we can get access to data. Otherwise, often it's very difficult for us to get access to data from fire events.
Can I go now?
Yeah, sorry.
So, Enrico, apart from institutions such as NIST, SFPI, or P, or NFPI, who else is interested in the modeling studies? I mean, do private clients also reach out to use evacuation modeling in their design projects?
I have to say that many of what are first my students, then they become engineers, fire safety engineers. And I always say in my class that statistically, one of you next year is going to write me because he's doing evacuation simulations and they have a question, and it always happens. So every year, I mean, not every fire safety engineer ends up doing evacuation simulations, but there is a portion of people that end up doing this for a living, or at least as part of their daily job or weekly job in fire safety engineering companies, especially those that work with fire safety engineering with performance-based design. Because, you know, when you use prescriptive codes like NFPA and other codes that are mostly prescriptive, you just apply rules. So you apply, you know, door widths, travel distance, and so on. So it's more of a mechanic job to check those things. But if you use performance-based design, then you have to enter the territory of simulations and so on. And it's more challenging. In a way, it's more difficult, but it opens up much more understanding to do a better design for fire safety. And that's where most of the students that end up working, that come from our education, do. So they use evacuation simulations for designing buildings. And generally, of course, you will not use this for residential 2-story house, but you would do it for maybe a big shopping mall or a big venue or a very new complex high-rise buildings. But it happens. So it happens that evacuation modeling is part of the tasks of a fire safety engineers. And as I say, it doesn't happen for every project, but for large projects where there's more complexity, it does happen. So I have many of my students that end up working for big companies that do this kind of project. Now, I don't want to name names of companies, but there are many of the big construction companies and fire safety engineering consultancy firms around the world that have people that are specialized into evacuation simulation. So many of these people, not being a big, such a big community, are either people that come from the research world and then go into industry, or there are people that are getting education in fire safety engineering. So people that come from the programs like ours and the one that we have together with Ghent, Edinburgh, and University of Catalonia. So those are the students that often end up working for this company doing this.
There are two other questions on YouTube that are related to modeling. So I'm going to ask them, and then Brenda is going to ask you something a bit different from modeling. So just for us to finish this subject, Gabriele is asking, how do you define populations for public buildings where the user may vary significantly? Elderly, children, adults, disabled persons. Do you select a worst case scenario that may not be realistic? I think you said something about using like stochastic modeling, so models for it, but I don't know if you can just add to this question.
I also have a recommendation on this, because there is a very nice chapter in the SFP handbook, which is one of the, let's say, biggest book in fire safety, which is called occupant behavioral scenarios. So it helps defining what behaviors and what populations you can insert when you design for evacuation simulations, for instance. So there is really a guidance into what factors to consider, which scenario, how many scenarios. So it's a very good guidance. This was written by Rita Fay from NFPA and Daniel Nilsson, who was a former colleague of mine here in Lund. So I really recommend to have a look at the SFP handbook for this, because there is a really good guidance then into how do I choose those scenarios. So what population, how many of this population, occupant loads, and all these kind of things. It's very much discussed there.
Thank you. And another question regarding modeling. Philippe is asking, going deeper on population behavior, does fire evacuation research area study wildfires and evacuation of animals?
Yes, I have to say that one of my other research track is on wildfire evacuation. So there is a surge in research in this domain, which doesn't look only into, let's say, traditional building fires, but you also look at the larger scales. The problem there is that the complexity is much higher because you have a larger scale. So what happens is that you need to simulate both the wildfire, and that's a problem on its own. Then you need to simulate what happens inside the building, so the decision-making and the behavioral response at the building level. But then those people get out of their houses, and since the fire is an outdoor fire, they also have to get to their cars, to their vehicles, or public transport, or whatever other means of transport they have. So there is also the part that concerns the evacuation on the road. And the effort that I've been putting with some colleagues has been to try to have these different models talk to each other. So to have wildfire models talking to pedestrian models, and to talk with traffic models. So we have actually done some work on this for NIST and then NFPA, together with NFPA and a couple of partners, including Imperial College, NRC in Canada, Movement Strategies, also RMIT in Australia. So we have a few people involved in this to build a platform called Winity that is able to have all these models talk to each other. Because at the moment there are models, but they're kind of addressing a specific problem, but you didn't have so much work into having, for instance, a pedestrian model talking to a traffic model, so that you have people first evacuating from their house and then going on the road and evacuating for a city, for instance, through a rural area. So that's a more recent research efforts that And there has been a few efforts in this domain, mostly in Australia, and with this group that has been funded mostly in Canada and US. So those are the countries that have invested a lot in this. Not only, but those are the countries that are looking a lot in this, because those are the countries that have a lot of problems with forest fires. If you think about California or Australia or even Canada. I mean, I always say an anecdote that together with these colleagues, some years ago, we thought about building a simulator of this kind to simulate an evacuation of 100,000 people. And when we put this bid together, the feedback that we were getting, oh my gosh, this looks like science fiction. It looks like something that is never going to happen. And then like the year after in Canada, there was an evacuation in Fort McMurray of 88,000 people. So they had to relocate 88,000 people. So something that was like a movie scenario that we were thinking, like a catastrophic movie scenario, became reality.
Yeah.
So this is happening more and more. With animals, I can say there is a very interesting research by a group in Spain that has been looking at this. And if you're curious about this, I suggest you to look at the group from Universidad de Navarra, because they have been looking a lot into how dynamics of movement change between animals and humans. And they have done experiments also with different animals. So I've seen things with sheep and also other type of animals to try to see what is the flow of animals compared to different type of animals compared to humans. So if you look at the group from University of Navarra and you look for animal behavior, and you will find a lot of interesting research there. And one of the main driver, I don't know how much you know about this, is because in Pamplona there, they have this bull ride. It's very famous. So they have a race between humans and bulls that make this, it's a tradition that they have.
Yeah, it's true.
So they're interested in this topic because they actually have humans running along with animals.
At the same time.
Yes. So they have a research track just on this topic. So I really suggest them because they specifically have put some research work into studying animal evacuation.
Interesting. So Enrico, you have been to Brazil already the last time in 2019, attending a GSI meeting, and Walter Negrisolo was also there. Do you intend to come to Brazil again? And what do you think? What's the importance of international collaboration to the fire safety area?
I think this is very important. And again, it was I had a very positive experience in the event that I attended. And on top of that, of course, Brazil is a wonderful country to visit. I always say also this to my daughter, because at that time she was in the belly of my wife when we traveled. So I say, one day I'm going to bring you back to Brazil. You don't know, but you have been there. So I say, one day we will come back and visit again. But I think it's very important to have this kind of global vision into research, especially in areas like the one where I work with, in which we are not so many people around the world that work on evacuation. So it's good to be aware and collaborate with different groups that are working on this. For instance, in Brazil, I'm familiar with the group of Professor Rosaria Ono that is quite known to work in this domain. So I had still contacts with her, and we probably know that me and her will be chairing the evacuation track in the next conference of the International Association of Fire Safety Science in Japan. So we will be the two people that will lead that track on evacuation. So what I want to say is that I'm very active in the international community, because we cannot really do our work locked in our offices. We need to make use of the research that the others are doing and trying to help each other, because we are not so many that do research in this domain. So if there is more research and we share research, everybody has to win from this. So I'm definitely interested in continuing international collaboration. And as I say, Brazil is one of those places in the world where you want to be anyway, even just for holidays. But again, I have a very good contacts with colleagues there. And as I said, now together with Professor Ono, we will be in contact further next year, because we will have to put together, a list of presentations for the conference. So we will be the one chairing the review process for this international conference that will happen in Japan in October next year from the International Association for Fire Safety Science. So we will definitely talk in the near future. So I hope there will be more opportunities to be there in Brazil. And I would be also very happy to meet the colleagues from Brazil here in Europe. The invitation is, let's say, two ways. And I just also want to mention another thing, that the next year we will also have the Pedestrian Evacuation Dynamics Conference in the Netherlands in June, which is, I think these are the two biggest events. And given the pandemic, pretty much nothing was happening in the last 3 years. So everyone is so eager to come back to a room and talk and discuss science. So these are the two big events to put in the calendar for those that are interested in evacuation. One is the Pedestrian Evacuation Dynamics Conference that is happening in June in the Netherlands, in Eindhoven. And I'm also part of the committee there, and there is going to be a very exciting program, again, very international. So we wish to have people from Brazil as well. And the IFSS conference, which, again, this is on the general fire safety science. So it's not just evacuation, but there is a specific dedicated track on evacuation that myself and Professor Ono will lead. So it will be very interesting to see the contributions in this topic, because these are both very highly ranked conferences that have researchers from all over the world coming and presenting.
And the second one is in Japan, and is it in February or?
It's in October.
October. Oh, sorry.
In February, it's the deadline for submissions of papers.
Okay.
I can send the information later on. While the conference is in October, in very close to Tokyo. So it's in Tsukuba, which is, let's say, an area close to Tokyo. So it's another nice trip to do.
Good.
As I said, it's a very good thing of our community that we kind of all, as I mentioned before, we all know each other. So it's before the pandemic, it was very common that we will visit each other. And, we have sometimes PhD defenses, conferences, and so on. So it's good that we are back, because it's been 3 years, basically, that we have not had the chance to travel at all, especially overseas, as you can imagine.
Yeah. So now talking about the benefits that modeling can bring to the fire safety area, and being a bit more specific about the subject, when we talk about fire evacuation modeling, we are dealing with hypotheses, probabilities, reliability index, random error, among other concepts. Can you explain a bit to us how these variables are defined?
Yes, I mean, the key issue there is try to understand what is your acceptance criteria, so-called acceptance criteria. So how much of the risk you are willing to accept based on the uncertainty that you have. And again, generally, when we talk about regular fire modeling, so fire modeling, you generally deal with uncertainty linked to measurement uncertainty, so the things that you're measuring, and then you have experimental uncertainty, which is more linked to the experiments when you collect your data, and then you have model user input uncertainty, so it's more like how you then translate this data into inputs that you use. When we come to evacuation, we have an additional layer of uncertainty, which is the so-called behavioral uncertainty. And that's what makes the difference between a deterministic model or a fire model when it comes to evacuation. So we need to put that component also in the picture. So when then we have our design, we need to consider all this uncertainty together. We will have a range. So we will not have a single value. We don't treat average values or just a single value. We generally have a range of results, and then we need to make an assessment of which percentile of our results we want to study. And then keeping account of this uncertainty, which has an inner assessment of all the errors that are coming along the way. Because again, when you do experiments, when you do all sorts of work to collect data, those are linked with certain things that do not necessarily have 100% accuracy. So there, then you can make this assessment and you can make this comparison. And what you will do then, you will work with safety margins. So you will work with the safety margin. You will say, okay, my time to leave the building is this, and I have this range of results. My time in which the conditions are still safe is this for this scenario. And then you have to make this call. What do I want to accept? So what is the uncertainty that I'm willing to accept? And then what is the safety margin that I want to use? So you will have to relate your safety margin to the uncertainty that you have in your simulation. Because again, not all situations, they have necessarily very large uncertainty. There may be a scenario which is a bit simpler because maybe you have a specific condition with very trained people, or you have not so many people, or you have people that have a very fixed procedure. Don't think about only, let's say, regular buildings. Think about maybe industrial facilities where may be a lot of training in how people what people should do. I make you a practical example. At some point, I had a project with CERN, which is the the European research unit that works with the nuclear research. So everything that has to do with particle physics. And they have these very deep tunnels, but they have often very trained people inside these deep tunnels. So even if you have a very sophisticated and complex facility, people before going there have to go through a safety training. So the population that you will find there is not the same that you will find in a regular building. So, and that's the kind of call that you have to make. What is your uncertainty compared to what type of population that you have and what type of scenarios that you have? So those are the concepts that you have to keep in mind, considering very clearly that when we deal with evacuation, there is this extra component of evacuation uncertainty that is the behavioral uncertainty. So it's not like we know people take 30 seconds or 1 minute to evacuate. We cannot know that, but we know a reasonable range. So that's the important aspect that I want to highlight.
And I will go back a bit when in the question that Brenda, I think, asked before about the international collaboration. Usually we think about international collaboration in the academia in terms of research, but this collaboration can be also in terms of teaching. And for example, nowadays with the we learned from the pandemic that we can use, for example, YouTube or a Zoom meeting or something. So it's much easier to do these collaborations in terms of teaching also, and this could be also something nice, not only in terms of research, but to share knowledge in between countries. So this is nice also. And so hopefully maybe we can discuss later on, maybe we can start some collaborations also between our universities. This could be really, really good.
For instance, I used to have, before the pandemic, I used to have an online course on fire evacuation design. So I ran it for a few years. The only reason why I stopped doing it is because then I became responsible for all the courses and the education that we had on fire safety here. So I had to prioritize that. But I found it an extremely successful way to have teaching in these more specialized subjects, because indeed, you can have a pot of students from all over the world and people who are not necessarily in location. There is a lot of project-based work to do. So it's not like traditional. I mean, online, you cannot just, stay in front of a virtual board for 1 hour. Otherwise, it gets boring. But there is a lot of more project work to be done. And you get an evacuation simulator, you get to try it. And nowadays, with the pandemic, we master all sorts of methods to control and supervise students online. So for instance, one thing that I had to do during the pandemic is to do like virtual computer labs, which is something that I never did before the pandemic. But you basically set up a system for which you can take over the computer of the person sitting at home, and then you can help them when they have a problem by having remote control or remote access and helping them navigating evacuation simulators and how to calibrate them. So that's something that it's definitely a good opportunity nowadays. And it's definitely something that we should push forward, especially because this is something that I guess many universities around the world, including us, will push forward anyway. So it is a potential there is a great potential with this that we should actually take advantage of.
Okay, so to conclude, we want to extend out to talk to your perception about how fire safety is taught in university and schools. I know this depends a lot on the country and the region, but so how do you think fire safety should be ideally taught in schools and universities? should this be included in engineering architecture courses, or should it be considered as an independent course? And how about the teaching for children and graduate students? What do you think about it?
I think that the best example that we have nowadays, and of course I am biased with that, but I was saying this even before being part of it, is to have a dedicated education on fire safety engineering. And just to make it clear, fire safety engineering is a broad subject that can be taught not just to engineers, but this is extremely relevant to architects, maybe people that come from a background of mechanical engineering or physics, and again, in this program that I was, and I am part of the MFSC program, where, by the way, we had several students from Brazil over the years. This is what we try to do. So we get this kind of mix of students that have backgrounds that are different: civil engineers, architects, mechanical engineers, people from physics, sometimes people that come also from, let's say, electrical engineers. So it's very wide. And then we teach them from scratch the basics of fire dynamics, the basics of human behavior in fire. And we start with very basic subjects, and then we learn more in more specialized subjects. What I think it's not good enough is just to have, a short, very short course that is too general. So, I mean, that's good to have an idea of the subject, but it's very hard to become a proficient fire safety engineer with a very short course. In that case, it's better to specialize on a more niche subject. Okay, I want to learn about this specific aspect of fire safety, and then I can learn about that. But to have a broad knowledge and to work as fire safety engineer, the way to go is to have a full education. And again, we are very lucky here because we have both an undergraduate program and a master program. We are part of the international program MFSC. But the ideal scenario would be that in many countries around the world, it would be this. Because as I said, as it is now, Sweden, along with a couple of more countries, is the exception, is not the norm. There are not so many. I had this discussion a lot, for instance, in my home country, in Italy, because they have tried a lot to push for a fire safety engineering program. But the maximum that they can get at the moment is a one-year program, which is still doesn't give enough time to digest all the complexity of fire safety engineering. So in an ideal world, we should have at least a master program of 2 years, or even better, like a full program, undergraduate program of 3 years. So the fire safety engineering discipline is concept and is very diverse. So it takes time to learn all this diversity of subjects. So my take is that we should push for more education worldwide. And as I said, we don't have to reinvent the wheel, because there are existing programs that are already structured. And for instance, the SFP is already a model for a curriculum for what subjects have to be contained. So you don't have to reinvent this from scratch if you want to start a new program. You can basically apply what is already existing in other places. And when it comes to postgraduate, there it's a bit different, because in postgraduate, again, we have a postgraduate program in fire safety also. So we have a PhD in fire safety. But there it's much more, again, driven by the individual expertise, research expertise that different universities have, because it's very difficult to have a university or a single institution, not just a university, that covers everything in fire safety. So it's almost natural that different universities specialize in a subject. Some they work more with structural fire engineering. Some, like here, we do a lot of evacuation and modeling. Or there are other universities that work in other domains, like industrial fire safety, wildfires. So there I see benefits in having specialized universities and postgraduate programs that focus on deepening a specific subject within fire safety, because that can also be linked to other domains, not just fire safety.
Yeah, it is indeed a broad area. And I remember when I started working on this area, because I'm a civil engineer, I thought that only civil engineers would be able to understand this area. And then I met Professor Felipe. I think I don't know if he's still watching us, but he was watching and he made some questions. He's a mechanical engineer. And then I just thought, oh my God, we need to share our knowledge, because it's indeed a broad area. and and then I met Morgani, I met Evandro. They are architects, and it's amazing how we can contribute to the area. So we really need to work together in this subject.
So I don't know if Enrico, you have anything more to share or talk to us.
One last thought is maybe that I really appreciate the fact that there is more and more interest in Brazil on this subject, because, as I said, and it's good that this is not just, let's say, after the Kiss nightclub fire, because the fear is when there is a tragedy is that there is interest only after the event and then things fade out. But it's very good to see that there is a persistent interest in the subject, and there is let's say, a growing research community of fire safety in Brazil. Because again, I was visiting there a couple of years ago, and I saw a lot of interest for the events that I attended. So what I want to say is that it's beneficial for everyone that every single country has a growing community of fire researchers, because we all have to learn from each other. So everyone can benefit from having growing national research communities. So really good job also in arranging this type of events, because those are what generally makes a community, being together and talk to each other, understand what problems you have, and trying to see what people outside are doing, to try to learn from them and maybe teach them also what you're doing, so that we can learn from each other. So I think that's the way to go. So really good job on arranging this type of events.
Thank you.
Thank you. So thank you so much. We would like to thank you for taking your time to be here with us. We also would like to remember that this episode will have available in our YouTube channel with Portuguese subtitles. We will work on it soon, so everyone will be able to watch it on YouTube. And Enrico, if you allow us just to finalize the episode in Portuguese, Evandro is here. Thank you so much, Enrico.
Thank you so much. It was a pleasure to have you here with us today.
Thank you.
Babu, mute.
Tu tá mutado.
Obrigado. Então, eu queria agradecer a presença do Enrico novamente, agora em português, mas também queria agradecer especialmente a presença das gurias que fizeram essa mão de falar em inglês, já que elas, além de especialistas em segurança contra incêndios, são especialistas em línguas também, né? E gostaria de lembrar, então, agora falando em português, o que a Brenda disse, né, que o episódio vai ficar gravado no nosso canal do YouTube, em breve com legendas, assim que o tempo permitir, tá? Sejam tolerantes. E também queria dizer que esse foi o último episódio de 2022, nosso primeiro ano, né, e que para a gente foi bastante emocionante, até a gente falou bastante durante a semana sobre o que era estar aqui nós quatro juntos hoje, num episódio internacional, primeiro. Quer dizer, não é o primeiro internacional, porque a Ângela já está fora do país há alguns meses, né? Mas é o primeiro com uma atração internacional, e queria agradecer a tolerância, a presença e a participação de todas e todos que estiveram com a gente esse ano, né? A gente está aqui de uma forma voluntária e ainda aprendendo a mexer aqui. Meu computador hoje está travado, né? Então eu estou falando na fé, mas está aqui, a gente está aprendendo a mexer e está fazendo isso porque a gente acredita que tem algo para contribuir na cultura da prevenção e da segurança contra incêndios, né? Então, a gente queria também lembrar a todo mundo que vocês podem participar através do Instagram do Firetalks, deixando sugestões de episódios e propostas para 2023. A gente vai dar uma paradinha agora no final do ano, mas em janeiro a gente está de volta. Tá legal, pessoal? Então, boa tarde a todas e todos, e obrigado por estarem aqui com a gente.
Obrigada. Thank you, Enrico.
Thanks.